All right. Well, first of all, welcome everybody to our biweekly free seminars. Today, Dave is going to talk about working with large LiDAR data sets. And he will cover importing LiDAR data from ASCII or LAS files. And he will also be showing you some techniques to improve performance, such as spinning outside a corridor or polygon. And as always, we will be recording today's presentation. Send you a link to the recorded video so you can pass it on to anyone who missed the presentation. And before we get started, just for those of you who are new to Softtree, we're based in Vancouver, BC. We develop civil design software. We've been in business for over 25 years, and we've got quite a number of clients. And our philosophy with designing our software is to make it easy to use. We focus on engineering over drafting. And we're innovative, and we provide speed and power to handle large problems such as LiDAR, which you will be seeing in detail today. And with that, I will pass on to Dave.
Thanks very much, Cam. Okay, today I'm going to start by just showing you that there is an example on our website that can help you find information about LiDAR data management. So let's go back to the home page, and I'll show you how to get there. We have something called support training examples. There's a few tabs here. If you go to the terrain tab and start looking for the word LiDAR, you can find this example that's pretty useful. I always use the Control F function in my browser, which pops up this nice little search tool here, and it doesn't take long to find what you're looking for. So the LiDAR examples come with a PDF and a bunch of files, and I'll just show you what that PDF looks like. Here we are. So it's a step-by-step how to document. Now I'm going to actually do some of that, and we're going to record this, as Cam was mentioning, so you can look at it later if you have to duck out for some reason, or if you want to pass it on to one of your colleagues. We'll be working with the terrain module. So Softtree's terrain module is where we do our surface management and so on. First thing I want to point out is that we can open LiDAR in all kinds of different formats. So here's all the various formats we can read. We can read LiDAR in ASCII, also in LAS, and sometimes you'll find LiDAR data in USGSDEM, which I'll mention later. I'm going to start with reading in some LAS data, and before I even do that, I want to do a little bit of preparation, because often LiDAR data files are huge, and rather than bring in the whole LiDAR data set, I'm going to do a little work first and make sure that I only bring in points that are of interest to me. Now here's a little terrain document that has in it a couple of roads and also a polygon. So I want to bring in some LiDAR data that happens to coincide with this. Now, of course, you have to have your coordinates lining up. We'll see that in a second. So let's do that. File insert. If I do file open, I'm going to lose this particular data set. And in addition, file insert not only allows me to add to an existing document, but it also allows me to select multiple files. Here I've only got 2 tiles. I'm in my all supported files, but I've picked my 2 LAS files. You might have 10 or 20 tiles. It doesn't matter. You can select as many as you want if you do file insert. Okay, LAS or LAS has various data points in it. You can't actually see what's in the file unless you click this Examine Files button, which can take a few seconds, so I'm not going to bother. I happen to know that the file type or the point type I want is ground, and that's all I'm going to bring in. It'll work great. Generally, you don't want to display points because there's so many. It just clutters the screen, but I will bring in the borders. Now, if I just say OK, it's going to bring in all the points, and this number up here, 79 million, is incorrect because it's including points that are in the file that are not ground. Again, if I clicked on Examine Files, it would it would tell me exactly how many ground points there were. But I do know that from experience that there's over 6 million points in here. 5 million is a reasonable limit for Softtree at the moment, so I don't want to bring them all in. Click on the Selection tab and Add, and I have the option to filter by region. I'm going to filter by corridor first, and I'll select a road feature. So that's one of the features that was in my existing terrain. So I'm going to say existing road is a corridor, make it 100 meters wide. Okay, there it is. Let's add another corridor. Unfortunately, you can't do multiple roads per corridor. You have to do one road per corridor, so I'll put new road in there as well. And finally, I'm going to add a polygon. Just a minute, I think I needed to do OK on that. And finally, I'll add a polygon. So you got to have the item selected, and like I said, you can't do more than one here. It just won't let you, so you have to do one at a time. Okay, polygon. So these are regions. The corridor really is a polygon too. All it's doing is building a line offset from the corridor center line and making it into a polygon. So what do I want to do? Well, I'd like to read these in with no thinning, so skip 0. But the default, I will skip 9 out of 10. So 9 out of 10, I'm going to decimate, remove all but 1 out of 10 points, and the rest of them I'll read in without thinning. Okay, let's see what that does. I mentioned that you need to have your coordinates set up correctly to start with. You certainly don't want to bring in well, if your data doesn't lie on top of your polygons and corridors, it's not going to help. So let's just click on cancel here, and it reminds me that you have to define a projection. If you leave this as undefined, it will just read it in without any conversion. If you have two different projections set up here, it will convert. And if you don't bother changing, there's no need to define projections if they happen to be the same. So undefined is as good as anything if you have the correct coordinates. However, if you want to set up the correct, whether it's UTM or people here often use the BC Alberts in forestry. Once you've set up the projection, you can use the data to define a lat long, and you can export to Google Earth and other fun things like that. I'm just going to leave it as undefined and carry on and read in my data. So there's one file. There's file number 2. Almost finished. So it doesn't take too long to read an LAS file. They're nice and fast. That's not true, unfortunately, of DEM. Oh, I was wrong. It's now on file number 2. By the way, if you have any questions while I'm doing the demonstration, feel free to type into the questions area. I'll try to notice and answer them. And yeah, we don't allow audio on the webinars, but I can read your question and answer it out loud. There's the data. Now, this is LiDAR as it comes off the machine. LiDAR is essentially a targetless laser survey instrument on an aircraft, sometimes on a drone. And it's picking up points on the ground all over the place. You can see that this is my existing road. It's got a corridor around it of dense points. This is my proposed road. It's also got dense points. And here's my square polygon, which is also dense. So if we zoom in there a little bit. Oh, by the way, you can also see that there's dense points here on this road. At least it looks like a road, and there's some dense points down here. Not quite sure what that's all about. And here we see a dense blob. what's happening here is that LiDAR data is best when there's no canopy or tree foliage cover. And so what we're seeing here is density in a logged area. We're seeing density where I asked for it, but we're also seeing density where there's a road, an existing road, no trees on the road, so we get dense points. So LiDAR data can be quite scattered. Now, in the area where I've said give me the full density, you can see that the points are quite close to each other. Let's just do a quick measurement here. There's a gap between points there of about 7 meters. In general, LiDAR people will tell you that you can get around 1 point per meter. That's clearly not the case here. 7 meters is quite a bit bigger than 1 meter. And the accuracy is on the order of 15 centimeters. It varies. I mean, if you've got a drone that's quite close to the ground, you'll get higher accuracy. Again, aircraft can fly slowly and close to the ground, or fast and high above the ground. You get different accuracies and so on. But ballpark around 15 centimeters. But where there's thick canopy, you're not going to get as dense data set as where the ground is open. And that's about all I wanted to say about A, reading an LAS file, and B, thinning your data. And now I want to go on to grid LiDAR, because an awful lot of LiDAR companies will convert the data to a grid and give you this beautiful, well, let's just open one. I'll click on my link over here and we'll open one up. Okay, so this is a little excerpt of a LiDAR file that I got from one of our customers. And it looks pretty nice. I'm looking in the 3D window here. But if we look in the plan window and show all the points, so the points are invisible, but if I select them, select all or Control A, you can see the points. And if we zoom in enough, you'll see that they are indeed in a grid pattern and they're 1 meter apart. So they've been resampled. Let's look now at the 3D window again and zoom in. Until we can see the individual points. Okay, there we go. So the points were sampled at 1 meter intervals, but what's that? That's a triangle. You can see quite clearly there's a triangle in the data set when you're looking at the shading of the surface. There's another triangle. Those triangles are between the real data points. So there's a data point there. Down here about 8 meters away, there's another one. Up here about 10 meters away, there's a third one. And that's the real data. All these dots in the middle, they were just interpolated. And these little zigzags that you see along the triangle edges are artifacts of the sampling. So when you get a grid data set, you're not really clear on the accuracy of the data until you zoom in and look at the 3D surface. And then you can go, oh, they didn't really have that many data points when they built this grid. And most of those data points are actually useless. So your data has been kind of expanded to look like it's very dense when it really isn't. Okay, there's a good reason to send your data to a grid, and that is to make it super dense by putting it into a DEM file. So here's another format that we can read. It's called USGSDEM. Let me just get to the right folder. Okay, so there's the USGSDEM. Now you'll notice in my list there that I have a whole bunch of different extensions. There's DEM, there's CATD.DDF. I don't know where the heck that came from. There's ADF, there's GRD. There's also TIF, which is also used for images. For some reason, these files tend to have a lot of different extensions, and sometimes our software is not ready to read the particular extension that you have. So it's not too hard to fix that. Let me just demonstrate quickly. I can just go into my module setup, import options, down to USGSDEM, and file extension. There it is. I can easily add one on the end. Just type it in. And of course, if you change this, I won't bother to change it, and you want to see it next time, you want to click on Save as Default here. So it'll be in your options, import options, next time you open Terrain. Right, okay. So let me open that file. And, oh, darn, I've lost my folder. There it is, USGSDEM. In this case, it's called DEM, which makes sense. Open. Notice that you have the same options. Well, some of the same options. You got the selection, you got the projection. Again, in this case, it does contain a well-defined coordinate system. That's great. And you've got the same options for selection if you want. I'm just going to bring this in. And here's the big downside for DEM files. They're nice and compact on the hard drive, but they take a long time to read in our Terrain module. So just be patient. This one's only got 100,000 points in it, and it takes quite a long time to read. So they can get 15 minutes, half an hour sometimes to read one of these files. Hopefully we can fix that in the future, but that's something to watch out for now. Okay, so once you've got your surface in, let's just go back to the file I was working on here. Once you've got your surface, or your points, sorry, on your in your terrain, then you're going to want to calculate a surface and calculate coordinates, contours. So no different from any other kind of surface model. You may want to limit the triangle sizes to be a little bit small because we've got points that are so close to each other. And contours, I generally don't like labeling because it takes a long time, and there's so many other ways to find out your elevations. There we go. Let's just let that go and see what we get for a surface. So the beauty of thinning the data this way is that I have contours and surface everywhere, so I can kind of see the context of what my surface looks like. But in the areas where I'm building roads and doing logging, in this case, that's what this is all about, I get very dense and accurate contours and also surface. And let's just look at that in the 3D window. So this model has in it 1.3 million points, I believe. Actually, a little bit less than that. Oh, I did remember when I did my calculation of triangles, I said 15 meters. Those holes there must be bigger than 15 meters. So the data outside the dense areas is sometimes got holes in it bigger than 15 meters in size. Let's go up to 50 and redo that. Shouldn't take too long. Right, while it's doing that, has my USGS finished reading in? Yes, it has. There's the border. There's no points visible right now. I'll just turn them on. There they are. So when you read in a DEM, you get a bunch of points. What it's actually doing is it's reading a file that is formatted like an image, and it's encoded so that each pixel has an elevation associated with it. So the pixels are read as elevations instead of colors. And let's just make a surface out of this, see what it looks like. There it is. So it comes with the triangles in it. You don't have to do a terrain calculation at all. The USGSDEM format has triangles in it. This is not a high resolution model. It's probably not LiDAR, but it could have been. Okay, enough of that. Any questions, anybody, about the various formats that you can get LiDAR in? One format I haven't shown you yet is, yeah, so there's the surface I read in from my LAS data. And when I zoom in, I can actually see that there's smaller triangles and more accuracy near the road than there is off to the side here. Yeah, it's a great tool, having a surface everywhere instead of just where the surveyor has been. Right, one more import format I'd like to illustrate is text or ASCII. So if I wanted to open an ASCII file, again, I need to go find the folder. There it is. So if I'm doing file open, I can select only one of these. That was a mistake. But I'll just do one for now. File insert would have allowed me to do two, but I would have had to clear my terrain first. Okay, I don't want to save this. And here's a typical ASCII file. It's opened up in the test tab because I was there last time. And as I go through next, it's reading these points and elevations correctly, so everything's good. But this is where you actually set up how it's being read. Sometimes ASCII files are in the opposite direction. Instead of X, Y, Z, it's Y, X, Z, so you would just flip these. That says column 2 is X and column 1 is Y. And of course now I'm going to get different numbers here when I look through there. Similarly, you can have different delimiters. So, for example, this is space and it works. But if I changed it to colon or comma, where's comma? There's comma. Doesn't work anymore. You can see I'm getting my Y value, but the other two are 0, so it's not working properly. So you do need to set up your structure properly. And again, if you change all these things, you want to save your import options to be as default so that next time you open it works. And I don't think there's much more to say there. You've also got the same selection tool, so you can use corridors and polygons and so on. So ASCII is really just the same as the other formats. It's just you have to set up a little bit to tell the program where to look for the points. Well, that's almost the end of my, oh, we have a question here. Oh, I've got a question which is related to creating contours. And I think I've got an example here that will, yeah. Okay. Question is, I was doing a creation of contours, and I ended up with contours that were the wrong range. You can see here that the start is 0 and the end is 550, and the actual range is less than that, so it works great. But if, for some reason, this number was set to 200, and I recalculate my contours, you're going to miss all the high elevation ones. And that doesn't usually happen when you start fresh. But if you've been reading data in from multiple files, oh, I wonder, oh, I only did that for the index contours, the 20-meter contours. So you can see there's no 20-meter contours going up above this elevation of 200. So why does that happen? Well, I'm not really sure, but it seems to me sometimes when you're bringing in multiple files and adding to your data set, this station range, or pardon me, elevation range here gets out of date. You need to manually set it properly so that it will read in or create, sorry, all the contours that you want. Hope that answers your question. Basically, just watch out and look at those numbers for both minor and major before you actually press the OK button. Now, I did want to mention that the course, surface data is used for all kinds of different things. You can use it for making images, for calculating profiles, and in our software, RoadEng, it's often used for roads. One of the things that's kind of interesting about LiDAR is that you can create a surface that goes everywhere, draw your road on it, and you've got cross sections, you've got everything. Let me show you an example of that. Just flip to the location design module. So this is road realignment near, it's in the interior of BC, and the idea is that the road goes alongside the river and they want to bring it up on this ridge top here. I'm not sure if this is going ahead or not, but I have some LiDAR data. Now, when I first did this design, I thinned out the LiDAR data and then just put the road wherever I thought was interesting and came up with a solution. However, the LiDAR data has been thinned, which means that the cross sections that I'm calculating are not as accurate as they could be. So here's a cross section, and there aren't that many points being sampled, and the cross section is as accurate as my surface. It's possible to switch surfaces when you're done. So what I did, let's go back to the terrain here. So the terrain that's being used here is this one. I've named it 300K because that's how many points it has in it. And that's there's all my data points. There's my contours. You can see it works fairly nicely. But I could now that I know where my road's going to go, I could use those thinning tools and I could create a surface with an accurate, a more accurate swath down the middle. And in fact, what I did is I just brought in all the data points, and this is what it looks like. So remember what that looked like. Let's bring it in with all the data points. And it's just more dense, a little bit more dense. So I get a more accurate surface. Especially in this area here, it looks like this is a railway track actually. Again, you can see that there's dense points where there's no foliage and not so dense points where the trees are thick. Right. So an interesting workflow in location is to actually do a preliminary design on a thinned LiDAR surface. So it's basically going anywhere you want, and then resample the LiDAR or reread it so that it's dense in the area of interest in your corridor. And rather than redesign the road, all you need to do is go into Module Setup, Alignment, Terrains, and just swap out the surface. So here's my low-res surface. Here's my high-res surface. Just swap it out, change the name, OK, OK, and location design, watch the cross-section there. That cross-section is now more accurate. And of course, the volumes are more accurate, and it'd be an interesting experiment to see how different they are from the low-res LiDAR to the high-res LiDAR. Well, that's the end of my demonstration for today. Any final questions? I do have a question here on the questions area. We added a shapefile for our road before importing LAS data. So we want, oh, you're wanting to pick up the elevations under the shapefile? Yeah, that's totally doable. We call it draping. I hope that's your question, Dave. Yeah, so if you've got a line on your terrain, don't have any terrains open right. Oh yes, I do. There's one. Let's go to this one. Sure. Okay. Now, if I bring a shapefile into this, before or after I read the LAS, doesn't matter. The shapefile is not going to have any well-defined elevation in general. So let's create something and pretend it's a shapefile. A shapefile would have 2D properties. Comes from ASCII or other, what are those things called? GIS systems, that's right. Okay, so there's something that may or may not have been a shapefile. It has no well-defined elevations. So if I actually look at each point there, it just says -99 for elevation. I want to see the elevations of the surface underneath, so I just change its properties. So select the feature, I've already done that, modify properties, Control-E would have done it, and turn on modeled, but not elevation. That drapes it. So it'll pick up the elevation of the ground. So as soon as I say OK to that, boom, there's an elevation well-defined on each point along here. And you can see it in a profile too. So there it is. There's a distorted profile. Yeah. Does that answer your question? Oh, it sounds like that didn't answer his question, but it was a great, but he liked the answer anyway. Okay. He was actually wondering about the station range here and whether it might have come in from the shapefile. It's not likely, but it could have come in from something like that, so we're not sure. Okay, any other questions before we call it a day? As I said before, this will be posted on our YouTube area, so you can take a look anytime. And just in summary, LAS, ASCII, and DEM files can have a lot of points in them, so you need to thin them often. And we've got tools in the terrain module for doing that thinning. And we've also got tools for display and profiling and so on and so forth, as you've seen. Thank you very much. Until 2 weeks. Bye now.